Now let's look at self-test 34.1. In this experiment, we have 0.45 gram of propan-1-nol. Now for Form 4 students, you haven't learned how to change this word to chemical formula, but for Form 5 students, you should know pro means 1, 2, 3. Pro means there are 3 carbons. Pan means all the carbon are singly bonded. 1, that means for the first carbon we have an OH group. Therefore, this is the structure for propan-1-nol. Now for Form 4 students, please try your best, okay, to understand. We have 0.45 gram of propan-1-nol is burnt completely in a calorimeter. That is this setup. This is the calorimeter, simple calorimeter, okay? A metal can calorimeter. The heat released in the combustion of propan-1-nol is transferred to the water inside the calorimeter. And inside the metal can, we have 250 cm³ of water, and the temperature change is 15 degrees Celsius. Calculate the enthalpy change of combustion of propan-1-nol. First of all, now follow the step that I have shown you before. Write down this first, heat released, so that you understand what are you doing. Heat released during the combustion of propan-1-nol is transferred to the water is equal to the heat absorbed by the water. And according to the equation, heat absorbed by the water is equal to the mass of water times the specific heat capacity of water times change delta T of water in Kelvin. Okay? Now put mass. Which one should I put? Can I put 0.45 gram? Is it correct? Now most students wrongly put 0.45 into this equation. What's wrong? I'm talking about water. Therefore, it should be the mass of water, not the mass of propan-1-nol burnt. So let's focus on water. We have 250 cm³ of water. And then look at an assumption. We have density. Density of water is 1 gram per cm³. That means 1 cm³ is 1 gram. So 250 cm³ is actually 250 gram. Do you understand? Times specific heat capacity of water is 4.2 units joule per gram per Kelvin times change in temperature. Change in temperature is 15, although it is given in degrees Celsius, but if you change to Kelvin, the change in temperature is also equal to 15 Kelvin. Do you understand? Because we are talking about the change, okay? So use your calculator. In unit joule, okay? Now what do you need to do? You need to work out the number of moles of propan-1-nol burned is equal to the mass of propan-1-nol, 0.45 gram, over molar mass of propan-1-nol. This is the formula for propan-1-nol. So look at the formula. We have 3 carbon, 8 hydrogen, and 1 O. number of mole of ethanol burnt is equal to 7.5 times 10 to the power -3. Lastly, work out the enthalpy change of combustion. Now bear in mind you need to write down a few words for your expression, combustion of propanol. Bear in mind the negative sign because it is an exothermic reaction. In this experiment we have and then over number of mole of ethanol burnt, which is and then over 1000, change it to kilojoule, which is -2100 kilojoule per mole. Have you got it? Okay. Bear in mind the negative sign. Okay, very important. But that's all for this test. Now let's move on to the next page. First of all, you need to calculate the amount of heat released during combustion. And then next, you need to calculate the number of moles of the substance burnt. Then divide the amount of heat released by the number of mole of substance burnt. You can calculate the enthalpy change of combustion. Usually, unit is in kilojoule per mole. Understand? Okay? Now, try class practice 34.4. Do it now. Look at the question. We have 2.6 grams of methanol was burnt in a calorimeter which contained 500 cm³ of water, and the initial temperature is 25.3 degrees Celsius. If the final temperature of the water became 50.1 degrees Celsius, determine the enthalpy change of combustion of methanol. It's not difficult. Now, pause the video, do it by yourself, and let's check the answer. Now, first of all, write down heat released in the combustion of what? Of methanol is transferred to the water, therefore is equal to the heat absorbed by the water inside the calorimeter, which is equal to the mass of water times the specific heat capacity of water times delta T. Okay? Substitute all the data. Mass. Can I put 2.65 into this equation? No, it's wrong, okay? Because we're talking about mass of water. Use the density of water, which is 1 gram per cm³. That means 1 cm³, 1 gram. Now we have 500 cm³. Therefore, mass of water is 500 gram times specific heat capacity of water, which is 4.2 joule per Kelvin per gram, times delta T. Delta T, it doesn't matter in degrees Celsius or in Kelvin, okay, in working out the delta T, which is 50.1 minus 25.3 in Kelvin, which is the delta T. Next, use your calculator. Draw. What is the next step? We need to work out the number of moles of methanol burnt. which is equal to the mass of methanol, 2.65 gram, over molar mass of methanol, 12 plus 4 plus 16. Lastly, work out the enthalpy change of combustion of methanol. What is the sign, positive or negative? Temperature is increased, so we must have a negative sign. 52080 joule over number of moles of methanol burned. You may keep the data on the calculator and then press this button and then times 52080 and then over 1000. Change it to kilojoule, which is 629. Now, because it is a very large number, it is not necessary to take to 4 decimal places. You may round it up to integer. 629, negative 629 unit kilojoule per mole. Have you got it? Yes, that's good.